Good day, this is your teacher, Sir Adrian. Today we will be discussing about prime numbers. Now, prime numbers is a prime number is a number that has exactly two distinct factor, which is one and itself. For example, 3. The only factors of 3 are 1 and 3, because 1 times 3 is equal to 3. Do you think you can think of any combination of numbers that you can multiply and the answer will be 3? There isn't, right? Because 3 has only two factors, 1 and the number 3 itself. Another example is 5. 5 has only one pair of factors, or two factors only, which is 1 times 5, right? If you multiply 1 and 5, you're gonna get 5. However, there isn't any other combination of numbers that you can multiply and then the answer will be 5. There isn't any, because the factors of 5 are only 1 and 5. That makes number 5 a prime number. Now, for this one, 7 is a prime number because it has exactly two distinct factors. The factors of 7 are 1 and 7, because 1 times 7 is equal to 7. Now, number 8 is not a prime number because it has more than two distinct factors, which are 1, 2, 4, and 8. Because 1 times 8 is equal to 8, and then 2 times 4 is equal to 8. That makes 8 not a prime number. So we have to remember these important facts. 1 is not a prime number because it only has one distinct factor. All right? It is not a prime number. It is also not a composite number. So you have to remember that. For 2 is the only even prime number. All right? And 2 has exactly two factors, which are 1 and 2. All right, remember the rest of the even numbers are not prime number. Only 2. That is even the only even number that is a prime number. Now let us try to circle all the prime numbers here. Remember that 1 is not a prime number, okay? So 2 is a prime number, right? So we have to circle that one. 3 is also a prime number because it doesn't have any other factors except for 1 and 3. 4 is not a prime factor because it has a factor of 1 times 4 and also 2 times 2. So that makes 4 not a prime number. 5 is a prime number because the only factor of 5 are 1 and 5. 6 is not a prime number because 6 has many other factors. We have 1 and 6. What else? We have 1 and 6 and 2 and 3. All right. For 7 is a prime number because it doesn't have any other factor except for 1 and 7. 8 is not. 9 is not a prime number as well because 9, the factor of 9 are 1 and 9. What else? We have 3 and 3 times 3. So that makes 9 not a prime number. 10 is not a prime number, all right? Because it has more than one pair of factors, which are 1 and 10 and 2 times 5. All right, so we only have 4 prime numbers here, which are 2, 3, 5, and 7. Let us try this one here. 15 is 15 a prime number? All right, for more than for digits more than 2 digits, for number more than 2 digits, all we have to find out is to check whether these particular numbers can be divided by 2, can be divided by 3, and can be divided by 7. Those are the only numbers that you have to think of. All right. Of course, we need to avoid numbers that are what? That are even numbers, all right? And also multiples of 5. All right. 15 is not a prime number because it is a multiple of 5. 17 is 17 a prime number? We will see. So it is not a multiple of 5, so it could be a prime number. Okay, how about, is it divisible by 3? To be able to determine whether a number is divisible by 3, you have to add the digits. For example, 1 plus 7 is equal to what? 8, and 8 is not a divisible number. All right, 8 is not a prime number. Sorry, 8 is not divisible by 3. So basically 17 is not also divisible by 3. Okay, let us try to divide it by 7. All right, 17 is not divisible by 7. That makes it what? A prime number. 19 is a prime number. 21 is not a prime number because you cannot because it has more than one factor, which are 1 and 21 and 3 and 7. Okay, 23 is a prime number because it has only one pair of factor, which is 1 and 23. So 25 is not a prime number because it has 1 and 25 and 5. 29 is a prime number, all right, because it doesn't have any numbers that can be divided or that can multiply that will result to 29 except for 1 and 29. So this makes it a prime number. 33 is not a prime number because you can divide 33 by 3 and you can also divide it by 11. All right, so that means the factors of 33 are 1, 33, and 3, and then 11. All right, let's change it into all. List all prime numbers between 30 and 60. Now, remember, the first thing that we need to do is to eliminate the numbers that are even and also the numbers that are multiples of 5 and also the double numbers. All right, those are the first thing that we need to do. So let's go with 31. Okay, what else? 32. We are not going to include 32, so we're going to do 33. We're not going to include 33 because 33 is a double number and all double numbers can be divided by 11. What else? 34 is not because 34 is an even. 35 is not because 35 is multiples of 5. 36 is an even number. 37, let's try 37. Okay, next 38 is an even. 39, okay, let's try 39. All right, what else? 40 is not because it's a multiple of 5. 41, okay, what else? 42 is not because 42 is an even. 43, let's have 43. What else? 44, we're not going to use 44 because 44 is a double number and also an even number. 45 is not because 45 is a multiples of 5. 46 is an even. 47, let us try 47. How about 48? 48 is not because it is an even number. 49, yes, let's try 49. What else? 50 is not because 50 is a multiple of 5. 51, let's try 51. And what else? 51, 52 is not because 52 is an even. 53, 54 is not because 54 is an even. 55 is not because 55 is a double number. All right, and then we have 56 is not because 56 is an even number. 57, let's try 57. And then what else? 58 and 59. So we were able to eliminate the double numbers, the even numbers, and the multiples of 5. Now we need to check whether these numbers are divisible by 3. Now how are we going to determine whether these numbers are divisible by 3? So we just have to add their digits. For example, 31 is 3 plus 1. 3 plus 1 is 4. So that means 4 is not divisible by 3. So that means 31 is also not divisible by 3. All right? How about 37? 37 is not. Okay, let's try to add 7 and 3. 3 plus 7 is equal to 10. And 10 is not divisible by 3. Therefore, 37 is also not divisible by 3. All right? Next, 39. 3 plus 9 is 12. And 12 is divisible by 3. That means 39 is also divisible by 3. All right, so we have to eliminate this. Next, 41. 41, 4 plus 1 is equal to 5, and 5 is not divisible by 3. So we can leave 41 alone. Next, 43. 4 plus 3 is equal to 7, and 7 is not divisible by 3. So we can leave 43 alone. How about 47? 4 plus 7 is equal to 11. And 11 is not divisible by 3. So we can also leave 47 alone. How about 49? 49, 4 plus 9 is equal to 13, and 13 is not divisible by 3. That makes 49 also not divisible by 3, so we can leave 49 alone. 51, 5 plus 1 is 6, and 6 is divisible by 3. Therefore, 51 is also divisible by 3. So we can eliminate this. 53, 5 plus 3 is not 5 plus 3 is equal to 8, and the 8 is not divisible by 3. That makes 53 not also divisible by 3. How about 57? 5 plus 7 is equal to 12, and 12 is divisible by 3. Therefore, 57 is also divisible by 3. That makes 57 not a prime number. 59, 5 plus 9 is equal to 14, and 14 is not divisible by 3. So we can leave 59 alone. Alright. So we have 31, 37, 41, 43, 47, 49, 53, and 59. Now, the last test that we need to do is whether this number is divisible by 7. That is the last. Alright. Now, 31 is not divisible by 7 because 28 is divisible by 7. Then plus 7 is equal to 35. That makes 31 is not divisible by 7. So 31 is okay. It's a prime number. 37. 37 is also not divisible by 7 because if we divide 37 by 7, that will equal to 5. And we have a remainder of 2. That makes 37 also a prime number. Next, the last test again is divisible by 7. Now, let us try to divide 41 by 7. And 41 divided by 7 is equal to 5. We have a remainder of 6. That makes 41 not divisible by 7, and therefore it is a prime number. 43. 43 divided by 7 is equal to 42. And we have a remainder of 1. That makes 43 not divisible by 7. Therefore, 43 is a prime number. How about 47? 47 divided by 7 is equal to 6. We have a remainder of 5. That makes 47 not divisible by 7, and therefore 47 is your prime number. How about 49? 49 divided by 7 is also 7 because 7 times 7 is 49. That means 49 is not a prime number. Let's go 53. 53 divided by 7 is equal to is equal to 7, and we have a remainder of 4. That means 53 is a prime number because it is not divisible by 7, which is our last test to determine whether these numbers are prime numbers. And 59 divided by 7 is equal to 8. All right, and we have a remainder of 3. That makes what? 59 is equal. That makes 59 not divisible by 7, and therefore 59 is your last prime number between 30 and 60. So the prime numbers are 31, 37, 41, 43, 47, 53, and 59. Alright, let us answer this last question here. List 3 prime numbers. No, I don't want 3 prime numbers. I want all prime numbers. Okay, all. Let's list all prime numbers between 20 and 40. The first thing that we need to do is to eliminate all the even numbers and the multiples of 5 and the double digit. So we will start with 21, 22, 23, 24, 25. 25 is a multiple of 5, so we're not gonna write it. 26 is an even, and 27, 28, 29, 30, 31, 32, 33, 33 is a double, 34, 35, 36, 37, 38, 39, and 40. Alright, those are the numbers between 20 and 40, but we need to check whether they are even numbers. They are prime numbers, right? So the next check that we need to do is what? Divisible by 3. And to be able to determine whether the numbers are divisible by 3, we just have to add their digit. 2 plus 1 is 3. That makes 21 divisible by 3. Next, 2 plus 3 is 5, correct? That makes 23 not divisible by 3. Next, 2 plus 7 is equal to 9. That means 27 is divisible by 3. That makes it not a prime number. Next, 29, 2 plus 9 is equal to 11, and 11 is not divisible by 3. Therefore, 29 is not, could be a prime number. Could be, we're still not sure because we still have one last test to do. 31, 3 plus 1 is equal to 4, and 4 is not divisible by 3. 37, 3 plus 7 is equal to 10, and 10 is not divisible by 3. Therefore, 37 is also not divisible by 3. 3 plus 9 is 12, and 12 is divisible by 3. Therefore, 39 is also divisible by 3. So we have the last digits here, correct? The last 4. Now, the last test that we need to do is divisible by 7. 23 divided by 7 is not. 23 divided by 7 is 3, remainder 2. So, this is your first prime number. 29 divided by 7 is equal to 4, remainder 1. Right? That makes 29 a prime number. 31 divided by 7 is also 4, remainder 3. That makes 31 a prime number. 37 divided by 7 is equal to 5, remainder 2, which makes 37 not which makes 37 a prime number. So your prime numbers between 20 and 40 are 23, 29, 31, and 37. Alright, I hope you learned a lot today regarding prime numbers, and I hope you will do well for your coming assessment. Alright, by the way, this is the last question. What are the prime numbers between 90 and 100? Alright, between 90 and 100 are, we have 90, 91. Alright, let's try 91. And then we have 92. 92 is not, because 92 is an even number. 93, let's try 93. 94 is not, because it is an even number. 95 is not, we're not going to use 95 because it is divisible by 5. It is a multiple of 5. 96 is an even number. 97, we will try 97. And then 98 is not, because 98 is an even number, and 99 is not also possible because 99 is a double digit. So we only have 3 choices here left, right? Next, the next test is what? Divisible by 3. So we need to add 9 plus 1. All right, 9 plus 1 is divisible. 9 plus 1 is equal to 10, and 10 is not divisible by 3. Basically, we need to leave 91 alone. Next, 93. 9 plus 3 is equal to 12, which makes 93 divisible. 9 plus 3 is equal to 12, and 12 is divisible by 3. Therefore, 93 is also divisible by 3. So we need to eliminate this. 97 is equal to 16. 9 plus 7 is equal to 16, and 16 is not divisible by 3. Therefore, 97 is also not divisible by 3. Now, let us try the number that are divisible by 7. Alright? That's our last test. So, 91, alright, divided by 7. So, this is 9 divided by 7 is equal to 1. 1 times 7 is equal to 7. Bring down, so minus 9 minus 7 is equal to 2. Bring down 1, and 21 divided by 7 is 3. 3 times 7 is equal to 21. Basically, 91 is divisible by 7. Therefore, 91 is not a prime number. Alright? How about 97? Let's try. 97 divided by 7. Alright? 9 divided by 7 is equal to 1. 1 times 7 is equal to 7. Minus, so that is what? 9 minus 7 is 2, and then bring down 7, that is 27. 27 divided by 7 is 3. 3 times 6 is 3 times 7 is equal to 21. Minus, that's equal to 6. That means your remainder is 6. Basically, 97 is not divisible by 7. Basically, the numbers between 90 to 100, there is only one prime number there, which is 97. Alright? Thank you everyone, and have a wonderful evening. Goodbye.